Exponential functions. Now, when you see the word exponential, that means we're referring to an exponent, of course. And in this case, our exponent is our variable. And then a is some number. We're going to use a number greater than 0, but not 1. And it could be any real number, but not 1. So what we're going to do is, we're going to look at a couple of examples just to get us started, so we can see how these things look. So I'm going to graph y equals 2 to the x. Notice the variable is now an exponent. So you're going to see something looks like this. Now this point is going to be 0, 1, and the reason why it's 0, 1 is because if you raise any number to the 0 power, because x is going to be 0, you always got to answer 1. Just keep that in mind. And we're going to look at the fact that if you look left to right, that's always increasing from negative infinity to positive infinity. And the domain goes from left to right. It exists from negative infinity to positive infinity also. And the range gets closer and closer to 0, but never gets there. That's why we're going to use parentheses. To infinity, down to up. It's getting closer and closer to 0, but we'll never get there. By the way, if you use your table key, if you keep on going negative x values, you'll see that the y values are getting closer and closer to 0, but they're not going to get there. That e to the negative 4 means the decimal has been moved 4 places to the left, so it's getting smaller, 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 smaller. So that's what that means. And plus, if you ask yourself, 2 to what power gives you answer 0, or in other words, can you get answer 0 when you raise 2 to some power? And you can't. You can take 2 to any number, any negative number you want, and you're going to get 0 as an answer. Now let's consider 2 to the negative x power. And it's going to look very similar, except that it's going the other direction. It's going down. Still have that point 0, 1. This time it's decreasing from left to right, from negative infinity, positive infinity. The domain and the range are staying the same. Zero is not included still. We'll never get to 0. So and the reason why it does shift like that is because this one is 2 to the x, and this one is 2 to the negative x. And if you look at your xy axis, we're going from a positive x to a negative x. Over here's a positive x, and over here's a negative x. So what we're doing is we're going over the y-axis. So if we take this part and flip it over the y-axis, we're going to get this. If you take the left side and flip it over the y-axis, we're going to get this. And if you're looking at this and your different things are going on with the bases, this is actually the same thing as 1/2 to the x. Because if you raise 2 to the negative 1 power, the way you get rid of that negative exponent, you flip it over, flip the base over, and change the exponent to a positive. And just to confirm, just so you can see with the graph, I'm going to just type it in, 1/2 raised to the x power, and you'll see it's the same thing. So in some books, you'll see it mention if the graph always looks like this if a is greater than 1 and is any real number. But if it's between 0 and 1, 0 and 1 not included, with x being positive that is, then it's going to look like this. And so just be aware of that if you're one of those people. What we're going to do is look at the transformation of y equals 2x, and this is how it's going to look. So what we're going to do, we're going to take each one of these and talk about how it changes. Hopefully you're seeing a link about transformations about a video of transformations that I've already made. So if you need to, take another look at that, a good look at it. The minus sign in front means you're taking all these y values and you're making them negative. So if you think about it, these are positive y values on this side of the x-axis, and these are negative y values. So when you go from a positive to a negative, that's over the x-axis. And then this minus 1, if you remember, since it's attached to the x, we don't use the minus, we change the sign, so we're going to see it's moving it right 1. And then this negative 4, if you remember, it's taking all these y values, it's going to shift it, or subtract them 4, which is moving them down 4. Applications of exponential functions. Now before we start doing some word problems, and I know you love word problems, let's see what the natural number e is. It's approximately 2.718. It is a natural number. You will see it with a lot of these compound and interest problems. I want to show you something. It's actually on your calculator. Now I'm using the TI-83 Plus. Now if you look above the division, you'll see an E. And you can see that's 2.718 blah 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 blah. E is a lot like the number pi. Its decimal never ends and it never repeats. Another place you can find it is above the ln key. Like the first power. It comes up, that one comes up with an exponent already, an exponent sign. Go to the first, we get the same thing. So if you're asked to find e squared, there's two ways of finding it. You can just hit second and then the ln key and then put your 2 in. And you get 7.389 blah 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 blah. I'm not going to write that down because you can see it up here. If I hit second, let's say I use the second division, I can then hit that exponent key and I can type in the negative 4 and hit enter. So there's a couple ways you can find the e key in your calculator. Now we're going to talk about some actual applications involving exponential functions. This is a common one. Hopefully you've seen it somewhere before. Compound interest. A equals P parentheses 1 plus R over N to the NT power. A is the amount that you're going to invest. It's your principal. It includes, let me take that back. A is the principal and the interest. It's the total amount. P is the principal. I got a little ahead of myself. Sometimes that happens. So A is the total amount. P is the principal. R is the interest rate. N is the number of compounding periods in a year. That N is the same thing. T is the time in years. So keep that in mind. Now, let's talk about the N a little bit more. If daily, hopefully you know there's 365 days in the year. Not every year, but we use 365. Some banks use 360. Weekly, hopefully you do know that there are 52 weeks in a year. Monthly is 12. Quarterly, there's 4 quarters in a dollar. That means there's 4 quarters in a year. Semi-annually is twice a year. Annually is once a year. So be aware of those. I'm going to pause a little bit. Okay, now I'm ready to go. So here we go. You want to know how much money is in an account? If you're going to invest $4,000 for 3 years, 4.1% interest rate, compound it. It's keyword monthly. Monthly means 12 times in a year. So here's the formula we're going to use because of the compound it monthly. So one that's just, it's above on your notes. So what I'm going to do is I'm going to substitute the P, which is 4,000, because that's what we're investing. 1 stays 1, plus stays plus. R is 4.1%. To make it a decimal, we move it 2 places to the left. So it becomes 0.041. Since it is monthly, that's 12 times in a year. So N is 12. And then 12 times T. T is 3 years. Now here's the way I do it, especially since we paid $100 for a calculator. I'm going to type it in. Here's how I type it in, because I don't like to do any work. 4,000. I'm going to type it in the way I look at it, the way it's written down. 1 plus 0.041 divided by 12, close parentheses, exponent. Now here's where we may differ in what we do. Yeah, 12 times 3 is 36. You can go ahead and type in 36, and that's more than fine. But sometimes these numbers can get kind of big or kind of strange, so I just like to put the exponent in parentheses because I want to make sure that it's going to calculate that exponent as one value. So that's why I'm using parentheses. And we get $4,522. And if I round it off to the nearest cent, that's 59 cents. And that's it. So you're done. Now if you have a scientific calculator, I'm going to do this once so you can see. What you want to do is you do want to do that 12 times 3 is 36. That is the times. So what you do is you do 0.041 if you're doing scientific step by step, or even a grapher step by step, which means I'm going to do inside the parentheses first. Then I'm going to raise that to 36 power. Then times that by 4,000. Same answer. So whichever method you prefer. For example, if you look at this example I have right here, you'll see a bunch of information about rabbits. But here's the basic function. It says use y equals 220 parentheses 2.7 times 0.04t. I easily could have written it as alpha, in this case alpha t equals 220 times 2.7 0.04t if you want to write it in function notation. Either way. But look at this one right here. It says that there are 220 rabbits in August. Find how many rabbits should be expected by next August. 220 is already accounted for in the equation, or in the function. But right now, if there's 220 in August, that means that we're starting with August of one year, and we want to know how many more rabbits there are by next August. So you have to use some real life thinking to be able to figure out how much time has elapsed. Now, since the rabbit population is growing monthly, we need to know, and this formula, this function is based on monthly time periods, how many months have elapsed from August of one year until August the next year. Well, if you know how many months are in a year, you should be able to figure out that's 12. So what we're going to do is we're going to substitute t equals 12 into our function. Now that means is, if I find f of, I need to find f of 12, which just means substitute 12 for t. Now here's the problem. How do you find that? We got a couple ways based on our calculators. I'm going to do it with the graphing calculator first because it is easier. In some scientifics you can also do it this way. So I'm taking out my graphing calculator because I'm a big fan of it. And I'm going to type in the function as I see it. 220 parentheses 2.7 close parentheses. And if you're wondering what the exponent key is that you need to use, it's this one right here. That's your exponent key. Now watch this. I'm going to hit parentheses again because I got two numbers in my exponent. I'm going to type that in all at once. 0.04 times. I'm using the times symbol in this case. The asterisk times 12. Close parentheses and then hit enter. That tells me I'm going to have approximately, well, it says round to the nearest whole number. So I'm going to have 354 rabbits. So the only issue is do you know how to use your calculator? Now let's say you have a scientific calculator. First thing you want to do, after you turn it on of course, you want to find the exponent. 0.04 times 12. You get 0.48. Now what do you want to do? Let's go ahead and find 2.7. And we're going to raise that to 0.48 power. Now this right here, this is why the x key, that's your exponent key. So I'm going to raise that to the 0.48 power. Hit equals. Then I'm going to times that by 220. I'm following the order of operations, in case you're wondering. So times 220. And we also get 354 point blah blah blah, but the nearest whole number. it still gives us 354 rabbits.